All right, so we're going to talk about the second section in the trigonometric graphs chapter, Unit 11, and we're talking about amplitude and period. And this is going to change what the graphs look like, but they're going to keep the same general shape. So they still have that wave form to them, but now they're going to happen faster, or they're going to have bigger changes from top to bottom. So since amplitude starts with an A, let's start there. So the graphs of y equals a sine x and a cos x are vertical stretches or compressions of the graph. So now, instead of always going between 1 and -1, the y values of these graphs can be found by multiplying the original y values by whatever that number is. So multiplying by a. So whatever that number is out in front there, instead of going from 1 to -1, now we're going to be going from whatever that highest part is to whatever the lowest part is. So A is called the amplitude of the graph. And it's the height above or below the axis, the x-axis, the graph will reach. Okay, so that number out in front is the amplitude, and it is the new height and the new low point. So we're going to jump right into this here. So on the same set of axes, we want to graph three things. We want to graph y equals sine x. We want to graph y equals 2 sine x. And we want to graph y equals 1/2 sine x. And again, you need to pay attention to what our interval is. So we're going from 0 to 2 pi. So right off the bat, we should know that we're going to be using the graph that starts at 0 and goes to 2 pi. So we can draw our axes in here like so. That was not such a good one. And then we're going to go ahead and label. We need to go all the way up to 2 pi. So let's go 1, 2, 3 here, so this will be pi over 2. Go another 3, which will be pi. Another 3, which will be 3 pi over 2. And another 3, which is 2 pi. So starting with the original graph, y equals sine of x. Well, we know that that starts at 1. So we'll go from 1 and -1. So we're going to be going, sine starts at 0. So 0, 1, 0, -1, sorry, that kind of runs into the numbers, and back to 0. So it looks something like this. Then we're going to do y equals 2 sine x. So now we're going to be taking that, and instead of going from 1 to -1, we're going to be going all the way up to 2 and -2, because this number out in front here says multiply whatever you get by 2. So our maximum here is 1, and we all know that 1 times 2 is 2. Our minimum down here is -1, and -1 times 2 is -2. So that's how we can find our new max and mins. So we'll go ahead and we're going to, again, still starts at 0, but now we go all the way up to 2, back down to 0, all the way down to -2, and back up to 0. So we'll sketch our new curve like this, and then we go on to the last one. So here we are doing 1/2. So instead of going all the way up to 1, we're only going to be going to 1/2. So we start at 0, go to 1/2, back to 0 to 1/2, negative 1/2, and back to 0. So this is going to be a little bit of a shallower curve. So it's going to be something like this. And this is the part that gets kind of neat, because now you can see that these three different curves all look really similar, but they have different heights. And what we're going to do next is actually going to compress them closer in together to make it even more complex looking. The important thing down at the bottom here is that everything shown here would be the same for cosine. So instead of starting at 0, you'd start at 1, and your curves would follow this pattern. They would just be higher or lower depending on that. Alright, so the second thing we want to do over the same domain, so we're still going from 0 to 2 pi. So we'll put our axes in here because that's our 0 to 2 pi axes. And we still want to go pi over 2, pi, 3 pi over 2, and 2 pi. But now we're doing negative 2 sine of x. So I will give you a hint that you're going to need 1 and 2 here, negative 1 and negative 2. But I would like you to try and graph this one on your own. So think about what it would mean if you were doing negative 2x, what would happen to the graph. So try that one on your own, and we will go over it in class tomorrow. So that was amplitude. Now we're going to talk about period really quick. And period and frequency kind of mix together. As you can see down here, we have period and we have frequency. So the graphs of y equals sine bx and y equals cos bx are horizontal stretches or compressions of the graph. So when you have an A out in front that stretches it up and down, when you have some number inside here, it's actually going to compress it horizontal. So if you have a slinky,
Can I use a calculator?
so these are horizontal stretches or compressions of the graph. Sorry about that interruption. So if you think about a slinky, if you stretch out how far it's going, the coils would get really, really opened up. And if you compress it down together, you'd have those coils really, really tight together. So that's what this is doing. It's either stretching it out horizontally or it's compressing it up really tight together. So B is called the frequency. And it shows the number of cycles that happen from 0 to 2 pi. So normally you would have one cycle happen. So on cosine you go up, down, up, which is one cycle from 0 to 2 pi. From sine it'll go up and down and then back up to 0. And for tangent you'd have 1.5 of those crazy windmills because that's one full cycle. So when starting at 0, which x value the first complete cycle would come to an end at is the period of the graph. So wherever the first cycle ends, that's your period because that's how long it took. So period, there's actually a formula for it, is 2 pi divided by the frequency, which is the number in front of your x value. Frequency is 2 pi divided by the period. So you will need to know those, but if you graph them, you'll still be able to tell where what your frequency is and what your period is from the equation or from the graph. So let's take a look at a graph here. So on the same set of axes, we want to graph y equals cosine of x, and we want to graph y equals cosine of 3x on the same interval. And again, this is from 0 to 2 pi, so we're going to use our 0 to 2 pi set of axes. So it's the one over here. And we're still only going to have 1 and -1 because neither one of these have a number out in front. So we'll use our same setup as before. So go out 3 of the big boxes, and that'll be pi over 2. Go another 3, and that'll be pi. Another 3 will be 3 pi over 2. And another 3 will be 2 pi. So we're going to start with our regular one, y equals cosine of x. Well, we know that that starts at 1, goes to 0, down to -1, back up to 0, and all the way back up to 1. So we have our nice curve here. And that is y equals cosine of x. Y equals cosine of 3x. Now, this happens one time from 0 to 2 pi. We want ours to happen, our next one to happen 3 times in there. So we want to have 1, 2, 3 of them occur in the same amount of time. So essentially what's going to happen now is you need to figure out, okay, well, how can I get 3 to fit in there? So on the surface you can say, all right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 3 will be 4 boxes each. So I should be able to see that after 4 boxes, one period is going to end here, one period is going to end here, and they'll be exactly the same. So what does that mean in terms of where we're going to land? Well, we know we start at 1, and our cycle ends at 1 also. And we know that dead center in the middle, we have to be down at the bottom. And then we know in between those two, we have to be at 0. So here's what one cycle of y equals cosine of 3x would look like. And then you would do the same thing with the next one. So that wasn't such a great line. Let's try that again. And we would do it again with the last one. So as you can see now, the red graph goes one time in there. The blue graph actually completes 1, 2, 3 full cycles in the time that the red graph goes down and all the way back up. So the difference here is the higher the number out in front, the more quickly it happens. So that's like increasing the speed. So you might want to make a note of that. The higher B is, the faster it goes. So that means that you're happening 3 times in the time that it would normally take for one cycle to happen. So what I would like you to do is, on your own, I'd like you to give this a try. And again, it's the same domain. So using our 0 to 2 pi set of axes, I want you to go ahead and try graphing y equals cosine of 1/2 x in this domain. So you're going to be going from 1 to -1. You still have your pi over 2, pi, 3 pi over 2, and 2 pi. So give that one a whirl on your own. And we are going to do one more example here together. So you're trying this one on your own. I would like you to we'll give this one a try and just on your own. And we will do this one here together. So the first thing I want you to notice, on the same set of axes, graph the equations y equals -3 sine of 1/2 x and y equals cos 2x, and our interval is now -pi to pi. So we are going to use our -pi to pi axes. So x-axis down the middle, y-axis down the middle, and now we're going to go -pi to pi. So I'm actually going to go out, let's see, let's go out 4. So this will be pi over 2, and this will be pi. 1, 2, 3, 4. This will be negative pi over 2, and this will be 1, 2, 3. Oh, can't go that many. On the other side, it doesn't fit. Sometimes you make mistakes and got to go back. So we're only going to go out 3. So pi over 2, pi, negative pi over 2, and negative pi. So the first one, y equals negative 3 sine of 1/2 x. So the first thing I notice is that I'm going to be going all the way to 3. So 1, 2, 3. And I'm going to be going down to negative 3, negative 1, negative 2, negative 3. And my frequency is going to be 1/2. So in the time I would normally complete a full cycle, I'm only going to get through half of one. So I know that sine starts at 0. And normally I would end up at negative 1 here. But because I'm at 3, normally I would end up at 1. But because I'm multiplying by negative 3, I'm actually going to end up at negative 3. And then because I'm doing half, I have to slide that over. So my next one won't be until way over here. Okay, and going the other direction then, so this would be my first part. Going the other direction, well, normally I would be at negative 1 here, but I'm multiplying by negative 3, so I'll be up at the top, and I have to slide out 1. So I actually end up over here. And I know this seems really confusing, but I want you to think now. I'm going to sketch this. You don't need to draw it, but this would normally go like this. So that's one cycle. We need to only get through half of a cycle though. So there's our half cycle. For the second part, it's y equals cosine of 2x. So that means it's going to happen twice as fast. Cosine starts at 1. It's going to happen twice as fast, so I need it to happen 2 times over the cycle. So instead of being at 0 here, I'm actually going to be all the way down at negative 1. And then I'm going to be all the way back up at 1 here. So it'd be something like this. And going the same in the other direction. So I need to be down here and then up here. And again, this would normally look something like this. So as you can see, it's compressed down in to make it quicker waves. So taking a look at that graph, I'm going to point out right here, just because I know the next question that's coming, that point right there. So it says, determine the number of values of x in the interval negative pi to pi which satisfy the equation negative 3 sine 1/2 x equals cosine of 2x. Well, they only crossed one time. So our answer for that would be a big whopping 1. Give those other problems a try on your own, please. And I will see you tomorrow. Have a wonderful night.